left off. And you should have this on your notes as well. Your standard normal curve says you have a normal curve, has all the attributes of your normal curve. It's symmetric about the mean median, and mode sit at the middle. You have negatives to the left, positives to the right. The this approaches the x-axis but never actually touches it. And this kind of fine-tunes it a little bit. This is where we're actually finding your z-scores from. In other words, these are your z-scores. Your z-scores are your standard scores. It's how many standard deviations away from the mean something lies. So if we started our mean with a 0 and we did a standard deviation of 1, this puts us on a standard normal curve. So therefore, if we're looking for a z-score of 1.5, we can find your z-score of 1.5. We can find the area to the left of it. We can find the area to the right of it. When we look up, if you remember, when we looked up in your table, it's always the area to the left. It's this area to the left because we read from left to right. Your cumulative area increases as your z-score increases, which means this. This is your percentiles that we did back in chapter 2. Remember when we did percentiles with your empirical rule? And we said, if you were over here, you were ranked in the 80th percentile, you were better than 80% of those students. And we added up all the percentages that were in there. It pretty much works the same thing. Cumulative area is from left to right. So we accumulate this area. So whenever we look up a z-score, and this is the most important thing, when you look up a z-score, and write this down somewhere, it's the area to the left. It's the area to the left of that z-score. And remember, I don't know if you remember back to Thursday, we said a good way to judge is at the halfway mark, it's half of 100%. So 50% of your area lies to the left, 50% of your area lies to the right. So if I'm a lot past the 50%, isn't my area going to be a lot over 50%? Yeah, it would make sense, right? So now, when we look up that area to the right, isn't that a little piece? Grab your table and find me the area for 1.5. I gave everybody a table. If you needed an extra table, I have them up here.
So 1.5?
1.5. Look up your standard deviation of your standard z-score of 1.5. And tell me what your area is to the left of that. Remember how to look it up on your table? Okay. Here's your z. You want to be the positive side, right? Here's your 1.5. And here's your 0, 0. That's the hundredths place. So it technically looks like this. Is it 1.5 the same as 1.50? Yeah. Find me this area right here. 0.9332. That means this is about 93.32% of your curve. Right? And we expected it to be more than 50%, far more. Remember, anything to the right or to the left of 2 is less than 5%. Right? Didn't we say that's unusual? Less than 5%. Anything to the right or left of 3 or negative 3 is very unusual. It's like 0.1% out there. So the large majority of our data is right in here. That's the area under our curve. Now, if I wanted the area to the right, I'm going to use the fact that the normal standard curve has an area equal to 1. I'm going to use this fact. So therefore, I can come over here and say 1 minus 0.9332. So in your calculators, do 1 minus 0.9332. Your total area has to equal 1, doesn't it? So if one part is 0.9332, the other one is 1 minus 0.9332, which is what? Thank you. Which is a little bit more, a little bit less than 7% of your data, of your area under your curve is to the right of it. The total area has to equal 1. Look at halfway through. At the halfway mark, this is at the, when z is 0. Look at in your table when z is 0. What's the area to the left of your curve on your table? 0.5. So isn't this 50% of your data? Yeah. Isn't this also 50%? 1 minus 0.5? Yes. So every time you look up something in your z-score table, it's the area to the left. If you want the area to the right, we're going to subtract it from 1. Another thing that this says is that we kind of need a cutoff. Your normal curve extends and extends and keeps on going, but we kind of need a cutoff for this. So we cut it off at negative 3.49. That's where your table cuts off. And at positive 3.49. So we technically say this. Anything to the left of this number is virtually 0. It's so negligible. It's virtually 0 to the left of that. Now look up in your table. Look up positive 3.49. Come all the way up, negative 3.49. Sorry, I'm on the negative side. Negative 3.49. Be careful of your negatives. They work backwards on the top. So there's your negative 3.49, 0.0002. So you are 0.02% area. That's how small it is. So for our intents and purposes, we say close to 0. If we go here to the 3.49, what percent do you think lies to the left of that number? 100%. Just about 100%, right? So there's hardly anything out here. This is a symmetric curve. See the difference? So we're using those as a cutoff. Your calculators go far more exact than this table does. And maybe tomorrow we'll take a look at how to find it on your calculator. But today I want you to just kind of get the concept of this. How we find these pieces. So we're going to incorporate your normal curve and your standard normal curve, and we're going to come up with all the properties that we need to use. Now, how does this relate to anything that you would like to do? Not yet. It doesn't relate yet. However, in another day or two, probably like Thursday, we're going to take these two curves and we're going to combine them, which you did this in Algebra 2. You said your mean was 50, your standard deviation 10. So you did this, 60, 70, 80. And you said, what would my standard deviation be for us, an x value of 60? And you'd find that you were 1 standard deviation above the mean. So we're going to say, what is the probability? We're going to turn these into probabilities that I pick a person who's greater than 60, less than 60, equal to 60, whatever it is I have to say concerning my x value. So we're going to turn your x values into z-scores and then use your table to find your probabilities. All this area under your curve equals 1. All your probabilities for one event, all the outcomes equal 1. So they are related. So today and tomorrow, our goal is just to see how do we look up these tables, how do we find our areas. Then Thursday, we're going to incorporate this into something usable, like for instance, the SAT scores. If they do an SAT score, and this is how they really do your SAT scores. Every college has a cutoff point. And you might have noticed it because sometimes, you know, if you take an SAT, your college comes back and says, well, we really need you to be 20 points higher. Can you just take it? Has anybody ever had that said to them, that they ask you to take it again? We need you to be 20 points higher. We need another 100 points on your SATs. Why would they come up with a random number like that? Because there's a cutoff point. So maybe out of, say, 10,000 kids, and there's probably many more than that, say out of 10,000 kids that take this test, they want the top 10% of those kids. So they figure out the mean, the standard deviation, and they find the cutoff score for that 10%. And they're like, I know I got so many kids that are applying. I want the cream of the crop. I want the top 10%. Bless you. So they say to you, you need to have an SAT score of this amount to be in my top 10%. That's how we use Z-scores. We figure out what the X values are, the mean, the standard deviation. We find out the 10% of our curve up here, which would mean 90% of our area to the left. And we're going to figure out what is that cutoff SAT score. That's how we're going to use your Z-scores. Unfortunately, it takes a little while to get to that point because first we have to learn how to look them up, and then we have to learn how to transform them to a Z-score. And then we're going to be able to figure out your top 10, your bottom 10, your lower 5, blah, 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 your middle of the road, all those pieces. So we did this part, and now we're going to flip to, we did to the left. Let's just look up one again. Let's just find another one to the left of this score. We can find the area under the curve to the left of the Z-score of negative 2.19. Now, the sketches are really, really important. All the way through this, we sketch. So right now, your sketch should look like this. Use the 0 as a reference, and just go like this. Negative 2.19. You want the area to the left. Your table, God bless you, your table gives you your area to the left. So look up in your table, negative 2.19. What'd you get, Aaron? Okay, now, does that sound reasonable? Sure, because remember our cutoffs were at negative 2 and positive 2? And didn't we say anything less than negative 2 is less than 5%? So does that sound reasonable then, that it would be like 1.5% just about? Use the fact that plus or minus 2 standard deviations give you less than 5%. Use the fact that plus or minus 3 standard deviations give you less than like 1%. Let's just call it 1%. We have an unusual and very unusual. This is even less than that. It's like less than 0.5%. All right. So how about finding me the area under the curve for a score of 217? If 217 is over here, do you expect it to be more than 0.143 or less? More. How come? It's more to the right, so doesn't it have a lot of this area over here? A lot more than 50%? So that's what you use to judge this. It's got to be a lot more than 50%. So now look up 2.17 in your table. I need everybody to be doing this.
Wait, why are you at 0.1? You mean 1.7?
2.17. And what's your area to the left of that? Aaron?
0.9
Good. Is there anybody that cannot find 0.9850? How am I doing this? We're using your table.
I know, but what do you go to? Like, you just go.
Okay, so your table looks like this. Here's your number. This is the ones, this is the tenths, this is the hundredths. Right here is the 2.1. Across the top is the 0.07. That's the hundredths. Okay, so when I add this together, that's my 2.17. So what you want to do is look for your first decimal on the left-hand side here. Look for your second decimal on the top. And see where they meet.
You already got 98.
You see it?
So 2.17 would be 9850.
9850. Did you get 9850?
Mhm.
Did everybody get 9850?
Mhm.
Okay. Let's try to the right of this. Okay, let's take this number.
Wait, Miss Mark.
Yes.
What is the formula for my question?
The formula, don't worry about the formula yet. We did the z-score before, but today we're just looking up areas.
R.
Okay. So to the left of 1.23. So here's positive 1. Somewhere over here is 1.23. I want the area to the left. Is it going to be less than 50% or more than 50%? More. So now, area to the left, I look up on my table. So look up 1.23. 8907. Did everybody get this? That makes sense, doesn't it? It's a big chunk of your curve. Now, I want the area to the right of 1.23. I want this little area here. Would be what?
11%.
Like 11%, because how did you get that? 1 minus. Good. It was good, Daniel. So if you subtract this from 1, your whole area adds up to 1, just like all your sum of your probabilities added up to 1, or 100%. We're going to leave ours in decimals. We're going to leave it in the 4 position decimals. And we're going to subtract. So 0.1093. Thank you. Now, doesn't that make sense? Look at how small that little area is. To the right over here, it's less than 5% to the right. Use that kind of like as a guideline. To the right or to the left of the -2 is only like 5%, less than 5%. So doesn't that make sense? I got a little bit more than 5%. You need to make it make sense. Now, here's the tricky, the in-between one. I want to be between -0.75 and positive 1.23. Now, watch what happens up here. Just watch for 1 second. It always finds your area to the left. There's my area to the left. Here's my area to the left. I actually just want this piece right in here. You subtract them. Not from the whole, but you subtract this area from that area. Do you see it? It's like punching it out. Give me the big one minus the small one, and I'll be left with the guy in the middle. So we're going to subtract, not the z-scores, we're going to subtract the areas. So find me the area for -0.75. And we found this one already, 1.23.
1.266.
Thank you. And we found this one already. Now, all you got to do is subtract your areas, not your z-scores. Just your areas. And that gives you the in-betweens. Thank you. Okay? And watch. Let's see if this makes sense. Between plus or minus 1 standard deviation is about 68% according to your empirical rule. Look how close I am to the plus or minus 1. A little bit over, but almost the same, right? So wouldn't I expect this to be about 68%? Okay? What I want you to do is to see past just looking up a number, subtracting it from 1, subtracting it from each other. I want you to make sense of your curves, because when we put these to applications, you're going to know immediately if your answer is feasible or not by looking at this saying, it can't be. I'm only supposed to get like this much percent. It's like my guesstimate. I'm going to guess. If you gave me this, I would guess you're real close to 68%. 70% I would guess at. So when my answer comes in, I know how I'm on track.
Do they always provide you with 2 of those?
If you have to do the in-betweens, yes. Yes. Sometimes what they do is, a nice in-between is usually like between 0 and, say, 1.23. So your 0 is this part, 0.5, and your 1.23 was 0.8907, and then you subtract them. You still always subtract, and you always subtract the larger minus the smaller because you can never have a negative area. You can have a negative z-score because it falls to the left of your mean, but you can never have a negative area. Make sense? Sure? Kind of. Okay. Let's have you try these two things. Find me the area to the right of the z-score of 1.06, just for this one right now. Find me the z-score to the right, the area to the right of the z-score of 1.06. Sketch your curve. Everybody should have a pencil in hand. Sketch your curve, shade it in. Be quick. When you sketch this, just go like this. This is all I want, remember? 0. Where's the 1? To the right. What do I want? To the right. So now, could my area be more than 50% or less than 50%? Less than 50%. So when I look it up on my table and it's more than 50%, what does it say I have to do? Subtract from 1. The sketch will help you. I look up 1.06. Hey, that says more than 50%. Oh yeah, I have to subtract from 1. 0.1446. Did you get that? No? Okay. So let's try this again. 1.06. You got that? And subtract this from 1. Yep.
Yeah, I got that.
Now, did you look up 1.06 in your table? Be careful that you're in your positives. 1.0. Go like this. Jada. 1.0 is on the left-hand side, and the 0.06 is on the top. Okay? Okay? Okay. Speak up if you don't have that.
If it was less than 50%, then we just keep that.
Well, when we did that sketch, then if we wanted to the left, that would give us more than 50%. Because we want to the right, we're going to subtract from 1. Yeah, that's why your sketch is helpful. Because you can tell right away that it can't be more. So that's when you say, how did I get more? Oh, I forgot to subtract it from 1. When you want it to the right.
So when you want to the left of the left.
It's exactly from your table. Okay, guys, one more. I want you to find me the area between negative 1.5 and 1.25. I want you to find me this area in between. I want you to find me the area in between negative 1.5 and 1.25. Watch the negatives, they go backwards. Your area that you look up is always to the left, which makes sense. If you want this little area, then you want this whole area. Where do they overlap? Is where you subtract them out. So don't you want a big chunk of this left? If you were going to guess, TJ, if you were going to guess, what would you guess your percentage would be? So guess for me. Like, look, I'm past the 1. How much is this area?
Middle?
Well, yeah.
5%.
Well, look, plus or minus 1
No.
is how much? 68%. 68 when you're plus or minus 1 is the biggest part of your curve. So it's got to be bigger than 68%, doesn't it? I'd probably go with like 80%, somewhere around there, if I was going to guess. So now, subtract, and what do we get? Okay, so it's about 83%, right? Leave them in decimal form. Yeah, but what you need to do is get used to sketching the curve. I'll come over there in a second. Sketch the curve. Notice if you want left or right. Use your shading. Because without my shading, like look at this big chunk of data. If I subtracted this and I came out to be 0.2 something, could that be right? No. I'm bigger than plus or minus 1. I'm more than 68% of my data. Okay, I'm giving you a homework assignment, and I need you to take this home.
The books?
Yeah? Or you could snapshot it.
Oh, that'd be better.
I'll let you snapshot it. It looks like a lot, but it's not. You're going to need your table. Page 243. Do you want me to yell out the numbers? 243. Page 243. Number 23, 24, 28, 29, 31, 33, 35, 39, 40, 47, 48, 49, 50, 51, 53, 55. Now look, the first, yeah, but look, they look like this. You're just finding areas you're just finding areas. Yes, I want to sketch. Make sure, guys, you give me a sketch.
We're on 59.
Hang on. Wait, hang on. Let's take out 39.
Take out 39.
Take out 39.
Take out 24, 20.
Take out 39 and 40.
39 and 40.
Take out 39 and 40.
28, 31.
39 and 40. Take those out. Nope, those are the only two. Good try, good try.